O'Neill, and today I'm going to be discussing what contaminated this drinking water. Before I begin, I'm just going to do like an overview of all of this. To figure out what the contamination is, you're first going to use charts. These charts are going to be the IR absorption peaks, which I will talk about a little more later. And then you're going to use these peaks to help you find the functional groups. And then you're going to use NMR to help you determine the ratio of the peaks to ultimately give you what is in the water. What is IR? IR is infrared spectroscopy, which uses infrared light to find out in the interaction with molecules. It measures the vibrations of the atoms when the infrared light goes into the substance, and when it increases energy, it measures these and it prints them off into a sheet, which we will show on the next slide. This also shows you the absorption, emission, and reflection of the substance in this. Here we have the IR of the contaminant. Right here you will see that it's around 15,000 in the wavelength. And then when we look at the chart, I pulled it back up here, you will see that this leads to a benzene ring, and that will narrow it down. We were given options of what this contaminant may be, and that narrows it down to 3 different options. And now looking at this is a group of functional groups. When looking at this benzene ring that I pulled up here, which is just an example, this highlighted red circle shows this is a functional group. It is the C to H, which is just a singly bound carbon to hydrogen. And then you'll also see this ring right here, which is a carbon-hydrogen ring. Now, what is NMR? NMR is nuclear magnetic resonance spectroscopy. This determines the purity and the quality of the substance that you are testing. You will place the substance into the spectrometer, and then it puts radio waves into the substance, and the substance is spinning while this is going on. This counts the different types of hydrogen atoms that could be in there and the numbers of these different types. This is then transmitted to a computer, and it is read on another chart, kind of like the IR one. When the photon is absorbed in here, like the radio wave is what is transferred. And now the NMR of this contamination, there's only one peak, which is this one right here. This one isn't a peak, which means there's no ratio. And on the given chart, we had different ratios and peaks for each of the substances, and out of the 3 substances that were narrowed down from the IR, there's only one of them that has no ratio and only one peak, which is benzene. This is an extremely hazardous liquid when found in large quantities. It is colorless, and it does have a very distinctive smell. It smells sweetly like gas. And normal levels of this do not harm the environment. It is found in like low-lying ozone layers. But exposure to high amounts are definitely fatal. If it touches your skin or if you ingest it, you will die from it. Exposure over time leads to damaged organs. And it is commonly injected into the environment from exhaust and from factories. And that is it.